Welcome to Stack 2020 and to the lightning session, How Much Testing is Enough Testing? This talk is divided into two segments. The first focuses on how product owners, stakeholders, and your development team can prioritize different kinds of testings. The second touches on design principles and pitfalls to avoid in order to write better tests. My name is Samantha, and I'm a software engineer at GovTech. You've heard of these before. Sometimes it seems that there's a new kind of testing that pops up at once every 3 or 4 days. And that's not surprising, because every time a new person tests a particular application, there's going to be a new way of testing it. But just because there is a name for it doesn't mean that it exists or that it's a kind of testing that we should employ in our system. Here's a map of some of the better known testing methods and methodologies. It's organized in a dichotomy, functional and non-functional, and breaks down into user, unit, integration, end-to-end, security, performance, and deployment. Now, there's a lot of tests, as you can see, and every day we know that the kinds of testings will only monotonically increase. So how do we then test all of these or employ all the kinds of testing methods that we know in the limited amount of time that we have for every project? It just isn't possible. So how? We're going to explore certain constraints and guidelines which will help us guide our testing. First of all, you should choose which testings to focus on based on your acceptable risks. What does this mean? For example, if you are an e-commerce website, you might want to focus more on high traffic user flows, such as a promotional flow before you release a big promotion on 9/9, for example, multiple redemptions of vouchers, 50% offs, high loads during redemption of vouchers. You should also choose which testings to focus on based on the nature of your application. So for example, if you were a government agency, you might have lots of integrations with different other government agencies. In this case, you might want to focus on user flows that touch on these integration points to ensure that your end-to-end flow through to your third-party integrator works. Requests go forward and responses come back all right. Now, this is back to our map, and using the colors, we've sort of highlighted perhaps a kind of standard for maybe a government application model. So for example, in government, it might be more important. Security is of high importance. So it's in red. And we do most of it. Deployment is also important because we can't afford for the services to go down during deployment. And of course, because we're very user-centric design and usability, or we try to be as user-centric as possible. And then if you have a very good dev team, they will definitely want to maintain your integration tests with your third party, as well as maintain a substantial unit test suite. Unit tests will ease the work of developers every time they commit new code because they can trust their tests to ensure that the code doesn't break any existing functionality. In this particular case, this might be a much more sparse kind of testing. It may be that you don't have enough resources. It may be that you're running on a very, very, very tight timeline. In this case, the team might opt to just do an end-to-end on specific use cases, user flows. It's not unheard of. I've been in situations, not at GovTech, but in other companies where the kind of testing that is employed is really one that is like minimal with hopefully maximal impact. You see that you have to neglect all of these non-functional requirements. And of course, you face the corresponding song. So if you are very, very high load app and your servers might go down? Is this a risk that you are willing to take? Or is it that you are not expecting such a high load and you might want to forego that kind of testing? This is a joke slide in the sense that this is a case where maybe you don't want to do any kind of testing. In this case, maybe you feel that you're ready to go out. I don't know. Who are the people who can define an application and its acceptable risk? Target users, stakeholders, and the development team, with the product owner pulling it all together. This is now the start of the second segment of the talk, how to guarantee the quality of tests. Red alert, designing tests, good tests, are very hard, extremely hard. It's much harder than you think. So as we embark on this journey, the first thing we should do is define what a good test is. So what is a good test? A good test will check that expectations are met and will pass when expectations are met. And a good test will alert when expectations are not met. So a good test should fail when expectations are not met. What does this all mean? Now that we know what a good test looks like, let's take a look at some anecdotal kind of advice and anecdotal sort of live productions of tests. First advice, know what you are testing. What do I mean by this? Here's an example of 2 unit tests, here and here. Quick glance through the test shows that, okay, they seem mostly rather similar up till this point. So if you see for the 2 tests, this state that they are expecting seems to be different. And if we were to refer to the names of the tests, it seems like both are returning models, but perhaps on different conditions. Okay, so maybe let's explore a little more on what this variable is actually encoding. So we see here, show TOU model equals show TOU model. Okay, now let's go back. Do you see it? The first test has show TOU model, and our second test, as we checked just now, this variable links back to exactly the same string, show TOU model. Is this a problem? This is a problem, right? Because what this means is that we verified that the whole structure of these tests are exactly the same, and now even their comparators are the same. So in conclusion, these 2 tests are exactly the same and testing exactly the same thing. The problem is it's mislabeled. So this second test says that it should be testing what happens in an error state. Yet this test is doing exactly the same thing as this one over here. So either someone forgot to actually implement this test or it was misunderstood somehow. Certainly the naming is off. Probably the next thing you want to do is just delete this test or implement it the right way. So you see the importance of knowing what you're testing. Next piece of advice. Write tests before development. I think this is something that maybe a lot of people are actually more and more familiar with because there's a movement, might have heard of it, test-driven development. What this movement is it encourages people to write tests before they start developing or writing any kind of code. The reason for this is that it really helps developers to shape their thinking and think about what they have to develop. So you don't just dive in immediately and start coding things without a plan. Writing tests before development forces you to crystallize your thinking into clear, achievable goals. And because tests have to be testing specific things, so these it makes your goals very, very specific. It forces you to do that. Another thing I like to pair with this is sort of this concept of the spheres of knowing. So what is this? Stuff I know, I know. So this is stuff that could help you in writing your test pre-development. You know what you are expecting, for example. Stuff I know, I don't know. So this could be like the implementation of your feature. So you might know what you're expecting, but you might not know exactly how to get from your current state to your desired state. But you know that you had to go and find out. Stuff I didn't know I know. So this is a bit more complicated to explain, and I'm not sure if it's tautologically or logically possible. But in a way, you can think of it in those instances where, for example, you might have a piece of information on hand, but you didn't know that you had it. Then, of course, this information then becomes useless to you because you have no way of accessing this information because you didn't know that you had it. The other bad thing about this is that you might be blocking someone who knows that you have this information and is expecting something from you, but you are none the wiser. And the last one is stuff I didn't know I didn't know. So this is an extension of the stuff you didn't know or you knew that you didn't know, but it's emphasizing the scope of what you don't know. So you might have thought that you didn't know this much, but actually the range of what you didn't know was much more. Perhaps that integration with that third party had a lot of other details that you didn't consider and didn't factor into your planning. So this is what we can consider a risk in the project. And that is why probably many project managers they tend to settle in some buffer in their planning stages for these kind of unknowables. But again, we don't know, we will never know how much buffer exactly is needed. It's more heuristic, right? Or based on experience. Last piece of advice, verify your test do something. So here's another example. It's a unit test. Sum of 1 and 3 should be 4. Okay, so let's take our first piece of advice. What is this test doing? This test is testing this function in the calculator class, the sum function. So what it's doing here is it's running the sum function, giving it inputs of 1 and 3, and it's asserting that the result is 4. Okay, it seems reasonable enough. 1 plus 3 is equals to 4. Now let's look into the implementation of the sum function. Seems to be a slight problem here. Do you see it? No matter what inputs I give to the sum function, I always return 4. Is this the right implementation of sum as we know it? Does 0 plus 0 equals 4? Does minus 1 plus 1 equals 4? I don't think so. So we go back, but consider this. If we go back to our original test, the test is going to pass because it just so happens that the test parameters 1 and 3 fit the constant return result of 4. Now I invite you to pause the video and think about how you might improve upon or modify this test so that you can catch that failing implementation. Did you think about something like this? One of the ways to tackle such problems would be to expand your range of inputs. So that is one common strategy. The reason why that test failed to do its job was because it only had one input. So if we thought about our problem space and the range of inputs that the sum function can support, we might come up with something like this. So summation can occur on negative numbers, on zeros, even fractions. So this test is attempting to broaden that coverage in the problem space. One way to improve this test even further is possibly to add summations of other fractions. For example, like these. In this case, this test will fail the previous implementation of sum because that implementation is going to return 4 on all of them, and it's not going to return 0, -1, or -99 on the second to fourth test, or fourth assertions, I should say. Okay, so now at this point, a friendly reminder. Good tests should break when things fail. Why is it necessary to make this reminder? I think a lot of times when we are in projects, we get caught up with the project, the things that need to be done, and we tend to try and we might have the tendency to ignore or try and brush over things that are failing. For example, like tests. It's natural, but I think it's good practice to remember that it's always better to fail early than to fail later in production. So if you see a failing test, do look at it as soon as you can. And if a test fails and passes with no apparent change, that is also a worrying sign because it means that your test might not necessarily be doing what you think it's doing, or it might not be very consistent. In technical parlance, we call them flaky tests, and you might want to fix those. Easier said than done though. We've had our fair share of flaky tests, especially on the UI layer and end-to-end when it's used for end-to-end. One last thing, don't trust code coverage tools. Nothing against code coverage or code coverage tools. I think they have their purpose, but they cannot be your only source of truth. It's easy to over rely on them because they give you quantitative numbers, and people tend to like numbers and greens and reds, things like that. But use them knowing what they do. What do I mean by this? So if you have used anything like, we use JCoco for example. If you have used anything like Coco or JCoco, understand that the previous test that we were exploring, the one that doesn't catch the return of a constant 4, that would have actually given you a code coverage of 100% on that sum function. The reason is that code coverage is just a static analysis, so it's going to give you 100% if you are able to if you run through a particular function. It doesn't tell you anything about the way that function was implemented, and thus it doesn't tell you about the quality of your test. So they are a source of information, but not a source of quality. With that, I will end my presentation.